Introduction. On this mission, we will learn the use of the autopilot and the navigation computer available on the Skyhawk. Contents. Launch from carrier. Climb to cruise altitude. Practice use of the AFCS autopilot. Using the Doppler radar navigation set. Use of the navigation computer. Practice the navigation to a shore airbase. If the cockpit interior is too dark, activate the flashlight with left Alt plus L. If the yellow cross cursor is not visible, press left Alt plus left Shift plus C to make it appear. Also, you can press spacebar to cut short long texts, in case you are repeating the mission. Before launch, we will begin the mission already hooked onto the catapult. The manual fuel control check has already been performed. 1. Trim. Set 7 degrees of nose-up trim. 2. Check for takeoff flaps, they should be set to half flaps. 3. Recheck the attitude gyro, RMI, engine instruments, trim indicators, and flap setting. 4. Ensure drop tank switch in pressure position if external fuel carried and ensure emergency wing transfer switch off. We are now ready to launch. Increase throttle to military power, and then give the crew a salute hand signal, by pressing left control plus left shift plus S. On the air. Retract the landing gear, with the G key or by clicking the highlighted handle. Once the aircraft clears the catapult and a positive rate of climb is established, execute a clearing turn to stay clear of the ship's path. Climb to 500 feet and fly parallel to the ship's heading, 30 degrees. Continue straight ahead at 500 feet and 300 knots, paralleling the ship until 7 miles from the carrier. We are near 170 knots, retract the flaps using the HOTAS or the F key. You are now at 500 feet. Maintain this altitude until 7 miles from the carrier. Maintain a parallel heading to the carriers, 30 degrees, until 7 miles from the carrier. You have reached 300 knots. Maintain this speed until 7 miles from the carrier. Your altitude is too high. Try to maintain 500 feet. Your speed is too high. Try to maintain 300 knots. Your altitude is too high. Try to maintain 500 feet. Climb to cruise. You are now at 7 nautical miles from the carrier. Accelerate to 350 knots, maintain a heading of 30 degrees and begin a climb to 5,000 feet, passing trough the cloud layer. You are now on a heading of approximately 30 degrees. You should maintain this heading for now. Good, you have reached your cruise altitude. Now level off the plane at around 5,000 feet. You have attained a speed of 350 knots. Strive to maintain this speed during the cruise, as the aircraft is heavily loaded. Automatic Flight Control System. The AFCS is the autopilot system of the A-4E. This system will maintain heading, altitude, pitch and bank angles, and perform a coordinated turn to a pre-selected heading without the use of the pilot control stick. It is managed using the AFCS panel located on the rear of the left console. Standby switch. Moving the highlighted switch to the standby position provides electrical power to the AFCS. This switch should be in standby at least 90 seconds prior to using any autopilot mode. When this switch is placed in the off position, all toggle switches on the panel will return to their off position. Now, flip this switch to the standby position. Engage switch. Moving this switch to the engage position activates the AFCS in one of two default modes, attitude hold or heading hold, depending on current flight attitude. We will try first the heading hold mode. For that, please raise the nose to 10 degrees nose up, while keeping the wings level. Good, you now have the nose 10 degrees nose up. Hold it and then flip the switch to engage. Good, we are now on heading hold mode and you can release the flight stick. The AFCS will keep the current heading constant and also the pitch up or down that we were at, in this case 10 degrees nose up. We can use this mode during long climbs or descents. Even tough you may release the stick, you still must monitor the airspeed using the throttle. Unfortunately, the Skyhawk does not have a warning lamp telling us which autopilot mode we are in. You can only tell by looking at the switches. Okay, now we will disengage heading hold. You can do so in two ways. By pressing the autopilot override button on the flight stick. Or by switching the engage switch off. Disengage the AP now. We will now try the attitude hold mode. For that, please, lower the nose to -5 degrees nose down and bank the aircraft 15 degrees to the right. Good. You now have the nose 5 degrees down and are banked 15 degrees to the right. Hold it and then flip the switch to engage. Well done. We are now on attitude hold mode and you can release the flight stick. The AFCS will keep the current attitude constant and the aircraft will start to slowly descend and circle to the right. We can use this mode during waiting circles or battlefield observation. Even tough you may release the stick, you still must monitor the airspeed using the throttle. In addition to the two default autopilot modes that we just tried, there are other modes that we can use. Altitude hold. This mode may be engaged when the current climb or descent is less than 4,000 feet per minute. Try it now, by flipping the highlighted switch to the alt position. Good, the aircraft will take a moment to adjust and then will maintain the altitude that you had at engagement of the switch. Note that the previous attitude hold mode was not cancelled by the new mode and so the aircraft is still circling to the right. But now it is not descending anymore. Pre-selected heading mode. To use this autopilot mode, you first select the desired heading using the highlighted knob. For example, Set it to 300 degrees. Next, enable pre-selected heading mode by flipping the highlighted switch to the heading selected position. Good, now the autopilot makes the aircraft turn, by the shortest route, towards the heading selected on the heading select indicator, on this case 300 degrees. Wait until the aircraft finishes the turn, we will use this time to explain this mode in more detail. Upon engaging the heading selected switch, the approximate pitch attitude will be maintained during the turn. If a level turn is desired, the altitude hold mode should be engaged by moving the altitude switch to Alt. The heading select switch may be placed in the off position at any time. If placed in the off position prior to the completion of a turn, the aircraft will roll smoothly to a level attitude and maintain the compass heading indicated at that time. Good, your aircraft should have leveled by itself on a heading of 300 degrees. While the switch is still in the heading select position, the set knob can be used to change the heading again. Let's try it. Use the knob to select a heading of 350 degrees. Good, the aircraft should be now on a heading of 350 degrees. Control stick steering mode. The CSS mode allows the pilot to fine-tune the aircraft attitude when the autopilot is in heading hold or attitude hold modes. Pre-selected heading and altitude hold are disengaged by use of CSS, and they must be re-engaged to be used again. When on CSS mode, the aircraft is controllable throughout the whole AFCS flight envelope, which is 4 positive G, 1.5 negative G, and 1/2 aileron deflection left or right. If these limits are exceeded, the AFCS disengages. Let's try it. Flick the engage switch off and on, to return to one of the two default AFCS modes. Press spacebar once you have flicked the switch. Good, you are now on heading hold mode. Next, bank the aircraft to the right 15 degrees. Be careful not to use more than half of the stick travel, or the autopilot will disengage. Good, you are now banked 15 degrees to the right. Now release the flight stick. Confirm that the CSS is maintaining the bank by itself. Now grab the flight stick and move it to the left, not exceeding half travel, until the aircraft is banked 15 degrees to the left. Very good, you are now banked 15 degrees to the left. Now release the flight stick. Confirm that the CSS is maintaining the bank by itself. Now grab the flight stick and level the plane. Okay, you are now level. Release the flight stick. Confirm that the CSS is now keeping the aircraft level. You can now try the same but with the nose pitch. The CSS should be able to keep the aircraft on a nose up or down attitude, provided you don't exceed the G limits of the autopilot. Finally, level the aircraft and press spacebar to continue. This finishes the AFCS lesson. Please make sure that the aircraft is on a heading of 350 degrees. Also, enable the autopilot on heading hold mode and with altitude hold enabled, so that we may proceed to the navigation computer lesson. APN 153 Doppler radar navigation set. This is a radar navigation equipment that uses the Doppler principle for continuous measurement of ground speed and wind drift angle. The Doppler radar set operates in conjunction with the navigation computer to provide navigation information to pre-selected waypoints. To operate the Doppler radar set, its selector knob must be turned on to either the land or sea position, depending on the terrain over which the aircraft will be flying. Once the radar returns signal permit measurement of ground speed and drift angle, then the set is switched to the normal mode of operation. Until this change takes place, the set is in the memory mode and the memory light on Doppler radar panel is on. In the standby position, all power except the modulator power required to drive the magnetron is applied to the Doppler radar set. This position is used when observing radar silence. When the selector switches on standby, the system goes into memory mode and the amber memory light comes on. Usually, this short equipment test is performed prior to the flight, but we will review it now to demonstrate how it is done. 1. Turn the selector switch knob to the test position. After a 5 minutes warm-up time, the memory light should go off, the ground speed dial should read 121 knots, and the drift angle dial should read 0 degrees. Currently, this warm-up time is not simulated and the test results appear immediately. 2. Turn the selector switch knob to standby. Allow approximately 5-minute warm-up. Not simulated. 1. Turn selector switch knob to the land or sea position, depending upon the terrain to be flown over. While this step is usually done prior to takeoff, for this mission we will do it now. Select the sea position. 1. Within approximately 30 seconds after the aircraft has reached 150 knots and an altitude of 40 feet, the memory light should go off. Currently, this activation time is not simulated. 2. After cruise altitude is attained, ground speed and drift angle should be observed to read within 50 knots and 10 degrees respectively, for the known condition of flight. Currently, only ground speed is simulated, drift angle not yet. 3. Bank and turns are limited to 30-degree roll right or left and or the type of terrain being flown over. If the above limitations are exceeded, the memory light will come on, indicating loss of tracking signal. 4. Similarly, high-angle climbs and descents should be limited to approximately 25-degree pitch attitude, or the memory light may come on if exceeded. The navigation computer will supply information to the pilot about his position, wind speed and direction, distance to destination, and bearing and ground track relative to true heading. The system can handle two waypoints, D1 and D2, in addition to keeping track of the aircraft's current position. Present position of the aircraft, in latitude and longitude coordinates, is continuously computed and displayed on the navigation computer control indicator. The magnetic heading to the target and distance to go is displayed on the bdhi. We will now review the controls and display windows of the navigation computer. 1. Present position. Latitude. Counter, in degrees and minutes, with a mechanical push-to-set knob. To operate it in DCS, you must press and hold the left mouse button and then turn the mouse wheel up or down. 2. Present position. Longitude counter, in degrees and minutes, with a mechanical push-to-set knob. On DCS, at mission start, both present position counters are automatically set to the starting coordinates. 3. Destination. Latitude counter, in degrees and minutes, with a mechanical and electrical set knob. Use this to enter the coordinates for D1 or D2 waypoints. On DCS, at mission start D1 will have the coordinates of the first waypoint set on the mission editor, while D2 will have the starting coordinates. 4. Destination. Longitude counter, in degrees and minutes, with a mechanical and electrical set knob. 5. Magnetic variation counter, in degrees and tenths of a degree, with a mechanical set knob. Magnetic variation, or magnetic declination, is the angle on the horizontal plane between magnetic north and true north. This angle varies depending on position on the Earth's surface and changes over time. 6. Wind speed counter, from 0 to 300 knots, with a mechanical set knob. 7. Wind direction, in degrees, with a mechanical set knob. Usually, the Doppler radar automatically computes these values. The wind knobs are provided for use as a backup in case the Doppler radar isn't operative. Currently, on the A-4E simulation the wind speed value is correct, but the direction value is bugged for now. We will now practice the procedures of the navigation computer. Prior to flight. The next few steps are normally performed prior to the mission, and in fact some of them were already seen on the M01 cold start training mission. We will practice them again during this mission. 1. Turn the navigation computer function selector switch knob to test. 2. Place the bdhi switch in the navcomp position, with a right click, so that the instrument will be linked to the navigation computer. Check the navigation computer counters, and the bdhi they should display the following. Wind speed, indicates 223, plus minus 2, knots. Wind direction, indicates 091, plus minus 2, degrees. Latitude present position, shows 01 degrees, 0 minutes, south. Longitude present position shows 001 degrees, 0 minutes, east. bdhi number 2 pointer, thin needle, indicates 30, plus minus 1, degrees right. bdhi number 1 pointer indication depends on present position and destination data set in. 3. Turn the function selector switch knob to standby. On this position, power is applied to all circuits except the present position integrator. 4. Now, turn function selector switch knob to the D2 position. We will input the coordinates of our waypoint number 2. On DCS, the D2 waypoint is initially set to the A-4E spawn position. For this mission, we will set it to Napa Air Base coordinates, which are 45 degrees, 0 minutes north and 37 degrees, 21 minutes east. Input these coordinates using the highlighted knobs. Next, turn function selector switch knob to D1, to check its coordinates. On DCS this destination is initially automatically set to waypoint number 1 of the route created on the mission editor. Currently, this waypoint corresponds to the coordinates of Jellinek Air Base, 44 degrees, 34 minutes north, 38 degrees, 1 minute east. You can press F10 and check on the map that these coordinates are correct. by placing the mouse cursor on the point and checking the coordinates on the top left corner. You can use the mouse wheel to zoom the map and left plus Alt plus Y to toggle the coordinate units if needed. 6. Set in latitude and longitude of present position on present position counters using push-to-set knobs. This is not really necessary on DCS, since the starting coordinates were automatically entered. You can check that they are correct by pressing F10 and checking the map. 7. Set in magnetic variation with mechanical knobs. Variations in degrees and tenths of a degree. The magnetic variation depends on which part of the world you are. For Caucasus on DCS it is 6 degrees east, so input the value 0060. Good. The DCS magnetic variation for other maps are: Nevada, 12 degrees east. Normandy, 8 degrees west. Persian Gulf, 1.6 degrees east. The Channel, 2 degrees west. Syria, 5 degrees east. Press 8. Set in wind direction and velocity. Use climb winds. However, if the Doppler radar is to be used, then this step is not needed, as this function will be automatically computed. Navigation. To fly to a selected destination, D1 or D2, turn the aircraft in such a way as to align the number 1 pointer, the thick one, of the bdhi with the top 12 o'clock dial position. You will then be headed towards the selected waypoint. Do this now. Select the D1 waypoint. Good. Now turn the aircraft until the thick needle is pointing to the top of the dial. Press spacebar once the aircraft is on the correct heading. The number 2 pointer, the thin one, should indicate the course deviation caused by wind drift, but this is not currently being simulated. The 2 pointers are both aligned at the top of the dial, like if it were a no drift condition. The current distance to the waypoint, in nautical miles, is shown on the small numeric counter, inside the bdhi. Now, fly towards the waypoint, until the distance reads 0 miles. Well done. You have reached the first waypoint. You are now over the Jelinek airbase. You can use the F10 map to confirm. Now, select D2 to navigate towards Anapa. Good. Navigate now towards the D2 waypoint. Well done. You have reached the final waypoint. You are now over the Anapa airbase. Perform a circling descent in a penetration pattern, to visually confirm that we are indeed at Anapa. Press spacebar once you can see Anapa's runway. Congratulations, you have completed this training mission. On the next mission, we will practice an IFR shore landing. See you then. Press spacebar to exit the mission.